Welcome to the Electrical and Electronic Engineering Lecture Series. Your anchor person is Professor Michael C. Ndinechi. Our topic today is Module 023, Understanding the Internet Technology, Part 2. Please follow me in this lecture series by subscribing to my YouTube channel at https://youtube.com/@ndinechimichaelc. Please like, share, and drop your comments in the comment section, or reach out to me using my email addresses. You can also listen to part 1 of this lecture, which is Understanding the Internet Technology, Part 1, when you get to my YouTube channel. Today, we are going to refresh our memory on how the Internet web session works. You see, anytime a user enters the World Wide Web address and clicks Go or Enter, a number of interrelated elements come into play. We will see those interrelated elements in Fig 1. But the first thing to know is the Uniform Resource Locator, known as the URL, and the IP address. You see, for every device that is connected to the Internet, it must have a unique IP address. IP address means Internet Protocol Address. This address is a 32-bit binary number, usually written as a series of 4 decimal numbers separated by dots, using the format 234.56.789.13. It could be any combination of decimal numbers, but it will be 4 separated by decimal numbers. So you see, for convenience, the World Wide Web uses familiar names called the Uniform Resources Locators that are preceded by letter www, that is World Wide Web, and followed by a domain name such as .com, which stands for commercial entities, .gov, which stands for government organizations, .edu, which stands for educational establishments, .org, which stands for non-profit organizations, and .net, which stands for network operators. For instance, if you look at page 1 up, you see that my email says michael.ndinechi@futo.edu.ng, meaning that I am from an educational or recognized educational institution, and that is why my email is bearing.edu. If you look at the Gmail home, you see that it is gmail.com, meaning that that Gmail is a commercial entity. So every resource device connected to the internet must come with one of such extensions: .org, .gov, .edu, .org, or .net. Now, the second thing that happens is that there is a domain name server. When a user enters the Universal Resources Locator on the browser's command, a request is sent to a domain name server that looks up the URL in a table and returns the IP address. Now, what happens is that if, for instance, you are looking for Michael Ndinechi at photo.edu, the system will place this URL in the browser's command line. Your browser could be Chrome, Firefox, Explorer, any of the browsers that are used. So when you place that name you are looking for that ends with any of these abbreviations, then that is sent to the domain name server to look up that name you have placed in the browser. When it finds it, it returns it with an IP address. We will see shortly in Fig 1. These domain name servers are arranged in a hierarchy so that if the local DNS does not have the address, it forwards it to the next DNS in the hierarchy. Take, for instance, you are looking for something. The closest DNS to you looks up that address you have keyed in the browser and it didn't see it. It will send that address to the next DNS in the hierarchy. That is the one a little above it. If for anything he didn't find it there, he sends it to the next one. It continues like that until he gets to the last one, which is called the root servers. We will see shortly. Now, look at Fig 1. If you are a dialing user and you dial in from our diagram, this dialing user is connected to backbone 2. Now, when he sends this his URL, the URL, you see the arrow going to the domain name server. We go to the domain name server. Now, this server is the one closest to this dialing user. For instance, you are in a university system and you have your own server. If the address you are looking for is not in the server that serves your university community, then that server serving the university community, which is the DNS for that university, we send it to the next higher level DNS, which we look it up to see if the address you are looking for is in that DNS server. If it is not there, he sends it to the next higher one in the hierarchy. When he finds it, he returns it with the IP address to the backbone. If he didn't find it until he gets to the last in the hierarchy, which is known as the root server, then the root server will send it through the network access point to another backbone, or through the private peering to another backbone, to look for it in the next backbone. Now, if for instance, in our demonstration here, what the dialing user looking for is not in backbone 2, then when the address is returned, it will follow the yellow arrow and go to the network access point, through which the network access point will send that request to other backbones to look up what the dialing user is looking for. We will come back to this diagram. Now, say at the top of the hierarchy are the root servers. So at this root server, if the address is not found, it routes the request through the network access point to another backbone to look for it. Now, when the device receives the IP address from the DNS, it generates an IP packet and inserts the to and from address. So automatically, that URL the dialing user has put in the browser will now come back from the domain name server having the address of the person or the device that sent it, and also the address of where it is going to. That is what we mean by to and from address. Then it forwards a TCP connection request into the network. TCP means Transport Control Protocol or Transmission Control Protocol. When the TCP connection is made, then the web page request is sent. That is what we have as the yellow arrow there. The web page request is made either through the network access point or through the private peering. So now, if the server is in the same backbone as the client, like in our diagram, the dialing user is in backbone 2. If the server is in the same backbone as the client, the router in that backbone will forward the IP packet to the destination. If the server is in another backbone, the IP packet will be routed to a network access point or a private peering point, forwarded into the correct backbone, and from there it will be routed to their destination. Now, the web page is now downloaded over the TCP connection in a series of IP packets. Let's quickly look at the diagram again. You see the green mark. So the green mark shows that from the backbone where the information is, we assume that it is this server on the right. You see, that server, because the URL, the IP address has inserted the to and from address to the URL, and that URL is found in this server on our right. Then that server will establish a TCP connection, which we marked in red. From that server, the packet of information that dialing user is looking for will follow the red dotted line and come straight to the dialing user that is looking for that information, because its address has been appended by the server that is controlling it, or the server in the backbone where it is connected to. So now say that the web page is downloaded over the TCP connection in a series of packets. Once the web page is downloaded, the TCP connection is terminated, and that ends the transaction. Now, we have what we call the cookies. Sometimes you are looking for something, the system will ask you whether you want to enable the cookies. Now, what does that cookies mean? The web server can also request for short files called cookies that provide information such as other websites or pages the user has requested. For instance, you requested for a file on wrestling. You put the address of a wrestling location URL and you enable cookies. The cookies will look for any other file that has that similar request you are making and present it to you if you enable the cookies. That is the essence of that, so that you have a lot to select from. Now, when that happens, even though each page requested involves a separate TCP connection to the web server, the user will have the impression that the whole thing are involved in one uninterrupted conversation. Sorry, not interrupted. In one uninterrupted conversation. Now, the seventh thing that will happen is the TCP recovery. So, if in any of those IP messages, their packets are lost during the download, the TCP automatically orders a retransmission, because it will be checking what is coming from the address. Is it what is coming into the dialing user's device that requested it? If it is not, it will on itself orders a retransmission. If any of the packets or any of the IP messages are lost during download, this TCP automatically orders a retransmission. If there are too many lost packets, TCP may quit and the download freezes. In that case, the client will have to hit the resend or the stop button. You can refresh. Some people call it refresh. Some people call it resend. So if you don't want to resend, if you've tried and tried, you can click the stop button. Now, that is how you communicate with the internet. If you look at what we have said, there is no means of security. There is no means of knowing who is doing what. So, for you to make use of internet and secure the information you want to send, you have to move to the next higher level of using the internet. That next higher level of using the internet is called the Internet Virtual Private Network. So he said that the most important aspect of internet development is its corporate usage, known as the Virtual Private Network, VPN. But as we go, you see that for many people, the internet is a consumer network rather than a commercial network. I'm sure that you must have been using the internet to download your pictures, download files, but you may not have thought of this internet as a commercial network. That is what we are going to see next. However, the greatest irony of the internet is that its greatest strength, that is, the ability to communicate with everyone else, is also its greatest weakness when it comes to security of data transmitted over it. Since no one is in charge of the whole network, it is virtually impossible to have end-to-end performance guarantees. The backbones are owned by different people, so no person controls what happens in the other backbone other than his own. From what we have said, if what you are looking for is in another backbone, in other words, the URL will go out from your backbone through the network access point to another backbone. So what you are doing in your backbone may not be what the other person is doing in his own backbone. So there is no performance guarantee as to what will happen. So we say that because of that, the internet becomes a very disorganized entity. So while the internet is assumed to be a big entity, it is highly disorganized. Each backbone carrier engineers the performance of their own network, but no one guarantees performance of traffic that flows between the backbones. So like any other packet network, when the volume of traffic increases, then the network delay and probability of losing packets will increase. Furthermore, it is possible for hackers to key in to intercept transmissions. Now, when this happens, it is called best effort. In other words, your system, the internet, is making the best effort it can to serve you. So we say that this best unsecure best effort is only acceptable for basic consumer services. You want to download something, you try to download it, it didn't download well, you are not holding any person accountable. If you are not satisfied, you refresh or you quit. So it is called best effort. It is unsecure. It is only acceptable to basic consumers. However, in commercial use, commercial users are looking for more secure and reliable services for their enterprise applications. This is where this virtual private network comes into play. To ensure secure, high-performance services for customers, corporate organizations typically opt for network services like the frame relays, we will talk about it later, that provide security and performance guarantees or give service level agreements. Sometimes you buy a software, you want to install it in your system, you will be asked to sign service level agreement. In most cases, people don't read it, they just click agreed. When you click agreed, it means that you have agreed to their level of service they want to provide you. So these internet VPN services were conceived to address the two primary reasons why corporate users did not initially consider the internet for their internal network traffic. Remember, the VPN is for commercial entities. When we talk of these commercial entities, I want us to look at, something like in Nigeria, JAMB makes use of internet, but when you are dealing with JAMB, you are applying for your award, you want to change your course, you want to upload your O-level results. See, you are looking at it as if it is JAMB network. It is really the internet network, but being used as a private network by JAMB. Because it is not private to them, it is termed virtual private network. So, why do internet users initially refuse to use this? Because there are concerns about access to and security of information sent through the internet. There is also lack of performance standards for network delays and packet loss to ensure that services operate as required. The key thing in defining this VPN is to determine which services is to be offered. Two possible services are available using different technologies. The first one is the remote access / dial-up VPNs. This supports secure dial-up connections and are used for accessing local area network-based resources remotely. So dial-up, remote access. I want you to get the two. That this type of VPN supports secure dial-up connections. If I am in my house and I want to connect to JAMB network to upload my O-level result, you see, I'm a remote access user. So I dial up into their VPN and make use of their local area network to submit what I want to do remotely. Then the next category is the dedicated wide area network VPNs. So this supports dedicated access with performance guarantees and are used for LAN WAN connectivity. When we say LAN, local area networks and wide area networks. If you look at your banks, for instance, when you stay anywhere, use your ATM to collect your money. See, there must be some guarantees that this person logging in or this card being used to log in is really belong to this account number and should be able to withdraw money from that. So it is called dedicated VPN because you are using a local one, but all those things are being owned by a set of organizations. So it is not just like any remote access, but a dedicated access. So now let's quickly look at this remote access. So that the working of the remote access or dial-up VPN is as shown in Fig 2. Here, instead of connecting to the LAN over a long distance telephone lines, the user accesses an ISPs network using a flat rate access number. What do we mean by that? See, in our part 1, we've shown how ISPs, that is Internet Service Providers, have their local area network through which they either resell directly to people for them to, use things like Wi-Fi or modem to, have access to them, and they charge them flat rate. So they use it to log into the ISP, and ISP now on their own link up every other VPN. So as the ISPs charge a flat rate for each user, this service is far less costly than long distance telephone services. That is, you trying to have fax or direct telephone link to where you want to send information. You can easily use your Wi-Fi to log in and send information because your Wi-Fi is part of the ISP's means of reselling services to users. So the next one is that security is a major concern when you make use of this remote access or dial-up VPN. Security is a major concern here since dial-up systems are susceptible to hacking. Therefore, it is important to address authentication and privacy in dial-up systems. Here, authentication is the task of ensuring that only legitimate users get access to the local area network. And privacy is the process of ensuring that all transmissions are seen only by the legitimate sending and receiving parties. Both of these issues are important in corporate networks, where it is imperative that sensitive information is protected from unauthorized access and corruption. While the internet configuration and pricing makes this type of VPN cost-effective, A technology called secure tunnel communications make it functional. We say that again. While the internet configuration of pricing, flat rate pricing, makes this type of VPN cost effective, a technology called secure tunnel communications makes it functional. In other words, this technology, secure tunnel, helps to, authenticate and provide privacy. So if we look at this figure, now to your left, you see your corporate LAN. This could be a very big organization that have their servers. It could be a bank, and each of the servers is in one of each of the branches. So you see the small computers that are now used to link up to each of the server. Now, this server has a gateway, sort of. This gateway is a firewall. I'm sure most of us have been hearing of firewall. This firewall is a device that helps to authenticate only authorized users to be able to get to this corporate local area network. And if I use organizations like JAM, for instance, when you want to do something, they want you to either sign in or register if you have not signed in before. So when you see such requests being made, sign in or log in, you see, trying to make sure that whoever that is having access to the corporate local area network is an authorized person. So if you look at that firewall, through the remote access server, it gets to the public telephone network. Here in Nigeria, public telephone network could be any of the GSM service provider, which otherwise are known as the cellular networks. And you see a dialing user up there that when he dials in through the public telephone network, like I said, in our case, any of the cellular networks, it goes through their network to the remote access server. That remote access server passes the information through a firewall server that helps to authenticate who the remote access user is before allowing the thing to get to the corporate local area network. So you see that when you have a dialing user who has a VPN client software, so it helps him to log in through the local dialing. You can see the traffic generated is encrypted and it passes through a secure tunnel through the internet services, through a secure tunnel, through the firewall and the router to the corporate local area network. So you see, it could be done in two ways: going through the public telephone network or through the internet services. But when it is through the internet services, the dialing user must have in his system the VPN client software. to be able to do that. And that VPN client software helps to encrypt whatever he's sending. By encryption, you help to maintain privacy, not allowing hackers to be able to take the information. If they succeed in collecting the information, because it is encrypted, they may not be able to decrypt it to get the actual information that is being transmitted. We also have another user here, which we say that it could be an ADSL. When we say ADSL, we mean asymmetric digital subscribers loop. We have in our part 1, talked about the ADSL, or people that use cable modem. We talked of modem as those small things like flash you connect to your laptop to be able to access the internet. So when you do that, also your system must have a VPN client software to be able to encrypt your transmission. And when it gets to the internet, it passes through a secure tunnel to get to the router that serves the corporate local area network. There are 4 primary elements in this type of VPN solution. One is the internet backbone. The remote user and the server can be on the same internet backbone or on a different backbone. The remote user can be connected on a dial-up or with an ADSL or cable modem, can be wireless ISPs, that is Wi-Fi, or any other high-speed access service. Then the authentication server is the server that confirms the username and the password before access is granted. And the firewall, the LAN, will be connected to the internet with a router and a firewall server. Then the VPN client software, the remote user device will always require special software that is provided with the firewall server. This special VPN client software and the firewall server together create an encrypted connection to ensure privacy. The privacy of the information forwarded through the internet once the user is authenticated is of importance. This standard approach is called secure tunnel. In this approach, the user's data is encrypted with the VPN client software installed in the user's device before being sent. At the corporate data center, in that diagram, on the left-hand side of it, where we see the corporate LAN, a firewall server unwraps the packet, decrypts it and the content before passing the information onto the LAN. Let's quickly look at that again. See to the left where we have the corporate LAN, the information that is coming through this encrypted secure tunnel will pass through the router and the firewall will decrypt it before passing it to the corporate LAN. So now we have the next one, which is the dedicated VPN. A dedicated VPN is an internet-based service that provides some level of performance guarantee. The delay talks about authentication and privacy. Now, the dedicated VPN moves one step higher, and that step higher is that it provides performance guarantees. We say, note that the traditional internet protocol datagram for best effort delivery means that the network can lose packets, it can deliver packets with error, it can deliver packets out of sequence, it can offer no assistance or no assurance of privacy, then there is no provision to ensure timing consistency. Now, at the beginning of this lecture, we talked about best effort. We said that for just internet consumer, best effort means that if he tries and he didn't receive, so be it. But if you are using it for commercial purposes, you can say, if you try and you don't receive, so be it. If you try and receive with errors, so be it. If you try and what you want is not what is given to you, so be it. It is not acceptable. So the internet moved on from dialing or users to dedicated VPN users, where performance is guaranteed. So this traditional IP forwards each packet on what is the least congested path at that moment. So each packet can take a different route through the network. I want us to get this. We have said in what we saw in Fig 1 that this, when the TCP connection is made, the server where the information one is looking for is located will be sending in packets of about 100 kilobits per second. Now, if he sends one, it doesn't matter to it through the route. He can send the second one, it follows another route. Sends the third one, it follows another route. But each one has the to and from address, so he knows where it is going. But along that route, it can meet some, difficulties and lose packets. It can meet some difficulties and finally deliver packets with error. It can meet some circumstances and finally deliver packets out of sequence. And it can not offer any privacy, any person can intercept it. So, therefore, there is no way of predicting the performance of that network. But the dedicated VPN tries to provide that service that is dedicated. So if we look at this diagram, before we now describe, we see the dedicated VPN. If you look at the left side, just like we have in Fig 2, the central site local area network, that could be your corporate LAN. Now, you look at the green cloud, which we call the Internet services with service level agreement inside. Then, to the right, you have different remote local area networks. And we now say that for this dedicated, the summary of the whole thing is that it makes use of virtual circuit, secure tunnel, and encryption not necessary. We will see why. So let's go down. We may have to come back to the diagram. So for this dedicated virtual private network, it makes use of a protocol known as the multi-protocol label switching, MPLS, and it makes use of it to provide dedicated VPN services with performance guarantees. This MPLS adds two important elements to the traditional IP, which we have been talking about. And the first thing it adds is virtual circuit. So here, all the packets for a particular session are routed on a virtual circuit. What do we mean by this virtual circuit? Now, a circuit is a conducting part that carries current from one point to the other on a circuit. So it follows that route until that current gets to the destination. Now, for communication system, this circuit is not there. That is why it is termed a virtual circuit. A circuit that seems to be there. We will quickly see why it is called a virtual circuit. So here, unlike the traditional connectionless, the Internet protocol here are making use of all the packets for a particular session to be routed through a path. This path is called the label switched path. Let's see it in fig 4 before we come back. So look at this fig 4 that makes use of this protocol called MPLS. See one end user, see the other end user. Before the two end users will communicate, there should be a circuit established. Look at the dotted line that is shown in red, that is established through which the packets from one end user to the end user will follow. If you remember what we said a while ago, the packets can follow the first packet can follow another route, the second one another route, and can meet any form of difficulties, which will make it to deliver out of sequence or with error. But in this case, the end user has established a circuit, that is a line through which end user on the left will get to end user on the right through that dotted red line. So when that is done, that dotted red line is called the label switched path. So it's a virtual circuit. Immediately it terminates. If it wants to connect to if end user on the left wants to connect to end user on the right, this path may no longer be available. Then it will have to follow from the IP router up, the one up, and come back to this one before getting to this end user. So in that case, it will re-establish another circuit. Because it is not permanent, it becomes a virtual circuit to get to the other end user. So let's get back. So we say that this MPL has two important elements, the virtual circuit, which we have seen. Also, it has the capacity for reservation. Before MPLS, we allow a label switch path to be established. It will ensure that there is sufficient capacity available to meet the requirements of the connection. Let's quickly look at that diagram again. Now, end user 1 wants to connect with end user 2, it established this label switch path. Now, what it will do next is, what is the capacity of the information a user on the left wants to send to a user on the right? If this part cannot carry that information, it will not start. But if you raise it and this part that is available can carry the information, it connects by establishing this label switch path, and like without resistance, the packet from end user on the right will get to end user on the left. If you look at the diagram, you see the packets put in blue color. So because it has established that it has the capacity and it has established the link, immediately it clicks go. Everything will follow that label switch to get to the other end user. So that is what it says, that by capacity reservation, that before MPLS we allow a label switch path to be established, it will ensure that there is sufficient capacity available to make the requirements of the connection, to meet the requirements of the connection. So you see that once the path through which connection will be made in the network is established and the capacity of the route ensured, then the network has the ability to provide quality of service, and it can be, can predict the performance with regards to delay or packet loss. That is what happens when you are doing a download. For instance, it will be telling you that 20 seconds remaining, 30 seconds remaining. You will see that because it has known the quantity of packets that are coming and the rate at which it is coming, then it will be able to predict that in the next 2 seconds, this download will be complete. If, for anything, the download network becomes poor, you see the time can extend. But a real commercial entity, immediately that is established, then the network must ensure that all the data is downloaded, or all the data from end user 1 must get to the other end user. That is when your system is able to provide quality of service and predict performance. When it predicts performance and guarantees quality of service, you say that there is service level agreement, and that SLA has been met. So we have looked at that diagram, the fig 4. You see how it goes. Now, one major difference between the dial-up and the dedicated VPN is that the MPLS eliminates the need for encryption and a secure tunnel. As MPLS defines the path over which each user's packet will be sent, while ISPs can now provide VPN services that offer worst-case parameters for packet loss and delays. When we say worst case, because it has established that this packet and this label switch path has the capacity to deliver this without interruptions. So you see that the worst case condition can be delivered. Now, the networks will then not deliver the type of consistent delay found in traditional circuit switched services. Performance guarantees vary from carrier to carrier and service level. But typical values will be packet loss of any MPLS should be less than 1% of the total packets to be delivered. The round trip delay must be less than 70 milliseconds, and the availability of the system must be better than 99.99%, which in communications we call 4 nines. This 4 nines is very important to any telecommunication person that deals with transmission of information from one point to the other. For instance, this availability, which in some cases, people can translate into reliability of the system. But let's look at it from the availability point of view. When you say that availability of any system is 4 nines, it means 99.99%. The layman's translation of it is that it can give 8.6 seconds outage in 24 hours. Let me put it this way. If it is a broadcast that, a broadcast is being made, and you say that that system being used has availability of 99.99%, the meaning is that if that broadcast is done in a day for 24 hours, the downtime or the outage time will not be more than 8.6 seconds. If it is 3 nines, that is 99.9%, then it will translate to about 1.44 seconds. Or 1.44 minutes. In which case, if you are listening to something and for 1.44 minutes, you are not able to hear the person while the person is talking, it means that you have lost enough that you cannot guarantee that you can repeat what the person said. But maybe it is 99.99%, that is 4 nines. It means that you have reduced the outage time to just 8.6 seconds, and you'll be able to fix what the person was saying within that time. So if you go ahead to have availability of 99.999, that is 5 nines, then it will be reduced further to just 0.86 seconds, which is highly acceptable. If you go to 6 nines, it will now come down to 0.086 seconds, which is highly negligible. So we say that for this MPLS, it gives an availability of better than 99.99%, that is 4 nines. In other words, you can get 5 nines, you can get 6 nines, and more. So it is very, very acceptable. In other words, the performance is highly guaranteed. So you say that one major limitation of these VPN service guarantees is that guarantees or only cover traffic that stays within that provider's backbone. Like we said at the beginning, if you are looking for information outside your backbone, there is no how guarantees can be given. But if it is within your backbone, then the guarantees are given, and you will be guaranteed that your performance or the performance of the system will be between 99, between 4 nines and more. An ISP cannot guarantee traffic that is forwarded through a network access point or through another carrier's backbone. Reason being that no one is in charge of all the backbones. No one is in charge of the internet. So for you to get performance guarantees, you must limit yourself to one backbone. And you know, backbones are not just geographically limited. A US backbone provider can have its own point of presence, different places in Africa, in Europe. Likewise, Nigeria's backbone provider, which is called the Galaxy backbone, should also have its own point of presence, which we call POP, in different locations, so that people trying to get into their network, assuming JAMB is using their backbone, people from anywhere can easily make use of JAMB's VPN to get access to their backbone. So now, finally today, we are going to look at circuit versus packet switching. In a circuit switching network, a fixed portion of the transmission capacity is assigned to a pair of use for the duration of a call. Just like we've seen in that diagram, a circuit is established between the two users, and while the two users communicate, that pair of circuits will not be available to any other person to use. The basic model for circuit switching is the public telephone network. If you call somebody on a landline, immediately the contact is made, you will continue to speak to that person until two of you drops. That line will seem to be engaged and no other person will make use of it. That is exactly what is an example of this circuit switching we talked about. But modern computers or modern computer controlled digital circuit switches provide that same type of dedicated capacity using what is known as computer bus. If you have followed my lectures on computer memories, computer architecture, you will understand what computer bus is. And it's just like a dedicated line connecting one device to the other. So you say modern computer systems can provide that level of dedicated capacity. On the other hand, the basic idea of a packet switching network is to send traffic in a series of addressed packets forwarded over a virtual circuit. We have seen what a virtual circuit is. So packet switching is when this packet has the address to and from, and as you forward it through a virtual circuit, virtual as if there is a direct connection. Some packet technologies like the Internet Protocol forgo the virtual circuit and simply let the packets find their way to the destination. We call that connectionless datagram. So a datagram is a one-way, unacknowledged packet that is forwarded without first establishing a connection. I give an example. If you sit and write a letter, unsolicited application to somebody, to an establishment, asking for employment, you did not first establish that they are employing. They are not bound to acknowledge that your letter. Even if they don't receive it, you won't know. If they receive it, you won't know, because it is unacknowledged, because you did not first establish a connection with them that they are employing. We call that in internet parlance a datagram, which is a one-way, unacknowledged packet that is forwarded without first establishing a connection. Network capacity is not tied up for a single user, but allocated dynamically to anyone who has traffic to send at that moment. That is packet. Obvious advantage of packet switching is efficiency, because it makes use of what is available, not dedicated. In packet switching, the potential traffic load is far greater than the actual network capacity, and in most cases it is oversubscribed, and all users vie for the same limited transmission resources. When they do that at the same time, then some will have to wait. Packet switching, therefore, incorporates what is known as traffic buffers. So, if there is a momentary burst of activities, the excess is stored in the buffer and sent as soon as possible. The buffers increase the overall delay in packet switching. Packet switching technologies include newer technologies like frame relays and asynchronous transfer mode, ATM. Mind you, this ATM is not the type you use to draw money, but a means of transmitting information or packets from one point to the other in such a way that it is difficult for hackers to access. So, stopping here today, thank you for listening. Hope that you will join us next time. We will do part 3 of these lectures on understanding the internet technology. That time we'll be looking at these frame relays, the internet services known as Wi-Fi, because that is common to many people, and this as ATM, asynchronous transfer mode, to see exactly how they work, so that you will know when you are using any one of them. Thank you for